This is the fourth edition, and this India Energy Week is really set a new benchmark as a strategic global platform for shaping the conversation around energy security, transition, and the future readiness of energy system. Against this, today's session is on asset integration and cost optimization under the category of organization readiness, operational excellence, and project management, which is particularly relevant in the current scenario. The session, I think, will bring real-time operational experience that demonstrate how digital technologies, advanced analytics, mathematical modelings, and strategic asset designs are being deployed to improve reliabilities, enhance efficiencies, and maximize life cycle values. We will hear 4 presentations today from power transmission, pipeline, city gas distribution, and petrochemicals, and each address about the asset optimization, which is not a theoretical construct, but it's execution challenges with a measurable outcomes. Each speaker will be given 15-minute slot to present. In the interest of time, there will be no audience Q&A. I request all speakers to strictly adhere to the timeline given. So I will ask first speaker, Mr. V. Thiagarajan from General Manager Power Grid to present his case study on AI/ML predictive maintenance, which highlights proactive asset integrity in large transmission network, supported by hardwares in loop and validated interventions. So I request Mr. V. Thiagarajan, give him a big clap to start.
Good afternoon, everybody. I'm V. Thiagarajan from Power Grid, and I'd like to this is a topic which the topic is organization readiness, operational excellence, and project management. Everybody know today in this electrical sector is one of the fastest growing sector in the demand for electricity is one of the fastest growing in the internationally because of 2 things. One, electricity, it is the most flexible form of energy which can be converted from any of the form, and second is the flexibility of transmitting over a very long distance with a relatively less amount of this thing at a low cost. So in order to have electricity which is flexible, and there is a need to transport electricity, we need a strong transmission system which is most reliable and also economical. So this particular session, we would like to see how we are improving the reliability at the cost. So if you see the transmission system, even no matter how you build it, if you have a 10,500 acres of a solar power plant generating 3,500 megawatts, or if you spend 35,000 crores, make a power plant generating about 3,500 megawatt of hydro, everything comes on one single transmission line which has only 2 circuits. So the reliability of that particular transmission line is very important, and if the outage of that will render the entire generation in a standard manner. So the importance of transmission is what the for reliable evacuation of power, we need a very strong transmission system which is reliable. So if you see the cost of the transmission system, it is roughly about 60 to 80 paise or so. But if the cost of the generation is more than, if you lose a generation unit, you lose more than 8 to 9 rupees. And the impact on the economy is multiple times of that. So that is the importance of the transmission system. So the national transmission system network are among the most complex networks and critical infrastructure in implementing sector in the modern economy. For operators to have a asset integrity management is a fundamental pillar for supporting reliability. The basic presentation in this is it shows the framework of this. The framework of asset integration. Okay. The framework of asset integration, it's a novel network framework in which we try to combine the generative AI, AI/ML, and hardware in loops for asset integration in power system. there is a shift in the methodology where we have preventive maintenance and also time-based maintenance. In this, we from the conventional time-based maintenance and also to what you call as the outage maintenance. We go for the shift to predictive maintenance to improve this thing. It's from reactive to predictive maintenance. It's a multimodal data integration which combines both the which combines more than one data to form a model in which we are able to ascertain the system. For example, you use the UAV, unmanned aero vehicle, under LiDAR inspection or digital telemetry for accurate thing. Similarly, in transformers, we use the DGA and also the IED-based integration for integration of this. The generative AI and AI create synthetic fault scenarios, and then we go from the readiness of this. In this, we have a generative creative synthetic fault scenarios, and the HIL ensures that the AI model is AI-driven recommendations are also safe and reliable. So if you see the importance of asset management, the conventional is reactive management, where you have when your asset has failed are very high. Because asset has failed, then we go in for the maintenance. This has a very high impact on it is a very forced outage risk is very high, and the impact is also, life cycle cost is also high, because the outage of an equipment is, has a very large impact on the grid. The second one is the time-based method. It's a fixed schedule method where you do a low and moderate outage. The impact is life cycle cost is high, but operational efficiency also is also moderate. But what we propose is that now we are taking up as predictive maintenance. And the predictive maintenance is a real-time condition monitor, where you see the usage of the particular equipment, and we try to use the age of the equipment. Various parameters are combined together to see the what is the effect of that. Then we measure the what you call as the RUL, remaining a useful lifetime, or the possibility of outage. For example, in a transformer, we see both the life of the transformer and also the overloading of it, or other parameters are seen, so that we are able to predict what is the need for the maintenance schedule. So this one is the what we are taking up now, predictive maintenance, real-time condition monitoring. In this case, the forced outage risk is very low, and the life cycle cost is lowest, and naturally the operational efficiency is very high. So AI/ML driven predictive maintenance, this is what we are talking about. It is a shift from the conventional reactive to predictive asset management. The operational and financial inefficiencies are traditionally taken up. The predictive maintenance enables by AI/ML. AI/ML models can accurately assess the asset health and also remaining useful lifetime, and optimizing the operational efficiency. That is the fusion. As we said earlier, it combines the two or more data. For example, we use the UAV method for combining the LiDAR and also the thermal imagery also to ascertain the transmission line fault conditions and in transformers we use the DGA and also the IED data for finding the transformers. Ensuring operational readiness through HIL validation, that is the next step we take, which is the HIL validation. So this one shows the impact of the AI/ML HIL framework. The AI driven, there are three curves in this. If you see closely, the red is the conventional method, and the black one is the actual method, and the green one, which is very small. If you see closely on the black line, it will see a small dots. That is the AI/ML predicted method. If you see closely on the black spot, you have a green dots, which is the AI/ML method. In this method, generative AI risk, here you have the what is called as the operational time versus the health efficient, number of operations versus the health of this thing. AI/ML models analyzes the multi-model system for remaining useful lifetime. The generative AI has for rare scenarios, it operates for the basically we use a digital twin for HIL validation and also the methodology and the framework development. The data sources, as I said, we have 3 data sources, real-time time sensors. One is the first for this we use the DGA method. DGA is the dissolved gas analysis in the transformers and also the partial discharged sensors. Then we have the digital substations. In digital substations, we have IEDs. The IEDs provide the intelligent electronic devices, which, as per the protocol of IEC 61850, give us a high fidelity operational data. So we combine both these data, and also, for example, in the case of a transmission system, for example, if you take the case of power grid, in the case of power grid, we have about 280 substations and 180,000 kilometers of transmission line. So a major part of our revenue is from the transmission line, which lies outside our campus. So the asset is outside us, and we have to ensure the reliability of that particular asset also. So what we do, in this case, we use the, that is for what I said, remote inspection data. We use UAV, and also UAV is the unmanned aero vehicle loaded with high resolution thermal imaging, and also LiDAR is loaded on that. It's a net for measurement of this thing, for ensuring the reliability of the data. So if you see this is the quantitative outcome of the operational benefits. The power in the case of power transformer, we use what is called as the deep learning methodology. In the deep learning methodology, we have the long and short-term memory methodology, and we are able to reduce the 18% reduction in the. We are able to predict up to 18% reduction in the RUL, that is the remaining useful lifetime error, and optimize the capex. In the case of circuit breakers, we are able to see the measure the anomalies by using ML. We are able to predict about 30 to 35 days of lead span in the case of a reduced forced outage of the circuit breakers. And transmission corridors also, we, as I told, we have the LiDAR and thermal fusion, by which 94% of the detected recall, we are able to improve the reliability. So this is the what we have in the we use AIML technology in this. But when we use AIML technology, we have to be sure of, there must be a readiness and there is be an impact. So the next step, what we have is this one, what we call as HAL validation for trust and safety method. In this particular methodology, we have what is called a hardware in loop validated framework. The hardware in loop, what it does is, unlike the conventional method, we have, in the hardware in loop method, we have the robust AI testing methodology. In this, we have, we create a digital twin of the network, and the digital twin of the network is gives an output to the device under test. And the AI, by AI method, we create thousands of different scenarios, and the scenarios are fed as the input for the digital scenario for the digital twin, and the digital twin gives the output to the device. From this, we are able to measure what is the behavior of the network, whether the behavior of the network is acceptable or not. We are both in the steady state and then the transient conditions. So this is what we propose in the next step of this thing. So, and reduced latency and safety proof. The validation reduced the anomaly to action to safety of to 60%, and it has enhanced the trust and adoption methodology. So this is the next step in what we have for operational readiness. So in just we have the organization readiness is for following form. Synthesis of AIML technique to improve the management of our asset. That is 80% reduction in the error of in a transformer, and also 30 to 35% lead time in the circuit breakers, 95% recall for vegetation. Then the second is the organizational readiness, addressing the trust barrier is deploying the mandated AI network. And to finally, summary of the next steps is shown in the figure. So, except for this part, I don't know. If you see the real-time data, so a summary of the step is We have the real-time data, digital data, and historical statistical data, which goes into multimodal data fusion. And from that, it goes into RAAML models. And then it goes into, right now, it goes into scheduled field intervention. The next step would be to refinement of the retesting and iterative feedback, and a hardware in-loop validation method, in which we'll have a digital twin and a physical control and protection hardware, so that we are able to verify what we have taken, and future deployment plan is to include this thing. So the acceptance and readiness is also there. So you are confident of using the model which you have derived is workable, and it improves your reliability. So this is the topic. Thank you.
Thank you, Mr. Thiagarajan. It's a really insightful presentation. And I must say that transmission reliability over a time has improved a lot. And since I am from the process industry, it is always a big question mark on the reliability of the electrical supplies to our refineries and process units. But of late, we have moved to the system where reliability of transmission has improved a lot, and of course the implementation of AI and ML tools is redefining the reliability aspects, and it's important for overall optimization, not only with respect to the usage of electricity, but also when we see these aspects in the operation plants, it is giving some edge to our process industries. Thank you. Our second presentation is from Keshav Kumar Dewangan, Senior Manager Integrity Pipeline, Bharat Petroleum. He will speak on the software-based pipeline integrity management system, demonstrating how probabilistic risk insight enables more informed, data-driven operational decisions. So I request Mr. Keshav to give this presentation.
Thank you, sir. First of all, I would like to thank IEW team for giving me the opportunity to speak on this August forum. So, pipelines are the arteries of the nation. This is the asset through which the energy flows into the system. So, here I will be speaking on the data-driven pipeline integrity management, how BPCL has transformed and evolved from the traditional approach of managing the integrity of the pipeline to the digital data-driven based, software-based implementation of the pipeline integrity management system. So why we need the different approaches to manage the pipeline? In earlier days, when the pipelines were very young, so we used to have a different kinds of data set that we used to measure on the going on the field. So there are various types of data. Starting from the construction data, we have evolved from the system where we used to have a paper-based pipe book, from where we went to the Excel-based. Now we are digitally adapted, data-driven pipe books are now being created in the pipeline system. So we have from the construction phase to design phase, operation and maintenance phase, and the retiring phase of the pipeline, we have a different kind of data set that may be or possibly we are utilizing those data set in the system. But we had that data set in various fragmented form that we need to collectively integrate it in the single referencing system so that we could able to predict the failure before it occurs. So industry has evolved from, oil industry is evolving from the traditional approach to the digital approach. Day by day we are changing our system, AI is coming. So data is very important, and data, quality of data and the availability of data is the prime concern. So with the limitation of the traditional approach is that we generally often overlook the uncertainties in the system. With the help of the new and advanced kind of risk assessment which is in place, with the help of this data-driven system, we could now able to predict the failure before it occurs. Let me give one example. As sir was explaining on the how the asset is being maintained in the power grid. Similarly, in the modern era of common corridor, Usually power grid and BPCL or any kind of asset operator co-locates in the same ROW and ROU, where the problem becomes very, very challenging and complexity, because we also faces the issues of corrosion due to the transmission line when it is in parallel to the pipeline. So if we mitigate in those area, there may be a chances of shifting of that interference from that location to other location. So that is the kind of uncertainty present in the pipeline system nowadays. So in BPCL, we have implemented software-based pipeline integrity management system. It was a need of ours to have a common platform in which all the operators, all the engineers in the pipeline system can able to see the data in single window. Even the management can also look at the single window where our risks are located in the pipeline system and where we need to allocate the resources effectively. To ensure the holistic approach to integrity, this was the very important aspect, which also have given a hand in terms of informed decision making in the pipeline system, how we can manage the integrity with the informed decision by taking the appropriate capex at that particular point of time, or we can advance some inspection interval so that pipeline becomes safe and we can continue the safe operation of the pipeline. As we move ahead, this data-driven integrity management system and the software lies in the two pillars. Mainly, one is the data management. All the data is operating or being stored in the SQL server, and there is different server which take care of the integrity management and analysis part. So all the data which we collected from the field is generally in the form of Excel. So we have a standardized template in which data is being recorded in the system, and that is uploaded into the data management pillar. So the data is being fetched from the integrity management part from this data management tool, and there is in between these two pillars we have two sets of layers. One is the risk engine. So in this particular system we have adopted a probabilistic risk model which predicts the uncertainty and which evaluates the uncertainty very well in the system. Also we have one layer of GS mapping in which we can easily able to locate those failure points or those risk zone, and we have also dynamically segmented all the pipeline assets in the pipeline in such a way that we can easily locate the risk and we can pinpoint the risk so that target intervention can be made before the failure occurs. Our digital integrity management system builds on these four pillars. One is the data integration. Second is the probabilistic risk modeling, in which as API defines the 21 threats to the pipeline, which can be a corrosion, crack, fatigue, weather-based, random events, lightning. There are number of threats. So all the threats are evaluated in the probabilistic risk assessment so that all combined threats become a single score for the risk, so that we can have a better judgment or better idea of ensuring the integrity. Then we have a dynamic segmentation in the pillar. We have decision support tools in which management can see how and where the intervention is required, because in our company, most of the pipeline is becoming more than 25 years old. So the remaining useful life of the asset is very critical in terms of operating the pipelines in safe manner. The most important part is the uniformity in the digital repository. So we have number of inspection data, like just to give you the example, once we lay the pipeline, we apply the cathodic protection system to the pipeline and we record the data once in a quarter. So that data becomes a backbone of any pipeline system, because this is the very important data for the assessment of the external corrosion of the pipeline. Similarly, we have a corrosion coupon and ER probe in place which records the internal corrosion of the pipeline. So this data we records from the day one once we operate the pipeline. Even when we construct the pipeline, from there only we start recording the cathodic protection data so that pipeline will safe. Then we have operations data. We have number of operation data. Our engineers record those data in the logbook in the form of pressure, flow rates, at what time the pumps are operating, at what is the shutdown time. So this data becomes also very important in terms of the fatigue assessment, when we see where there are any chances of pressure-based fatigue crack in the pipeline. Then assets. In pipeline, if you see, we have every 1 kilometer we have test lead point. That is the basic minimum requirement for operating the pipeline, because there we record the readings of cathodic protection. Similarly, we have number of river crossing, railway crossings, water body crossing, power line crossing. So all the assets we can capture in this digital integrity management system in a single place, so that any risk due to that third party also can be evaluated effectively with the risk assessment. Then pipeline, as we follow the shortest route in the pipeline, but once we traverse through the different terrain, we have number of bends in the pipeline. So the bending strain also becomes crucial to evaluate. So we do the inline inspection of the pipeline once in a 5 years, 10 years based on the severity of the pipeline. There we also record the bending strain, and further we can analyze that in this digital integrity management system. So overall, this data effectively captured in the system with the standard template is a key to maintain the integrity in terms of the data-driven integrity is concerned. Then comes the main heart of the digital data-driven integrity management system is the probabilistic risk assessment. You often heard the term HAZOP and QRA study. So QRA is a quantitative qualitative risk assessment in which the fixed scores are assigned to the sum of the threads. But in case of the risk assessment, it is not a binary condition whether the pipeline will be safe or fail. It is the dynamic probability that evolve over the period of time. So you must have to combine all the threats and all the possibility of failure with the degradation mechanism like corrosion, fatigue, crack, or any kind of, like there may be a random events also like third party damages, because the pipelines operates in the city also nowadays. So this all threats combined together, we can have a combined risk of single score, so that we can have a expected financial loss, expected societal risk, expected safety risk to that pipeline system, so that we can have a targeted intervention at that particular point of time. Just to give a figure, like it is a kind of a weight balance system in which in the one side of the weight balance system you have the risk to operate the pipeline, in the second side you have the expected loss if the risk is not mitigated. Now you have the option to choose whether you want to live with that risk or you want to expend so much of money to mitigate that risk, so that you will avoid the expected loss due to that risk. So this is the kind of system which we have implemented in BPCL. Then here comes the digital dynamic segmentation. It is very important because the pipeline attributes are different in miles to mile basis. Generally, earlier approach used to be we generally select 1 kilometer or SV station to SV station section to define the risk. But once you select the different physical attributes to the pipeline, we have a varying wall thickness, we have a varying pipeline grade, the depth of cover is different, the coating is different. So there may be a chances of different segments of the pipeline. Whether we see as a single pipeline, it is different. But we see as a pipeline as a number of thousands of segments in which the risks are different. So even if you have been allotted a 1 crore budget of repair and maintenance, you can effectively allocate those resources to that particular location where the risk is very, very high. So it eases your task so that you can manage the integrity better. So here comes the decision support and visualization. You can see here with the help of this graph where the possibilities of risk in this pipeline system. So all the risk inputs in the form of data is provided to the risk engine, and the decision logic, the mathematical model evaluates the uncertainty very well so that it provides the risk. It is based on some kind of simulation. So it basically gives us the picture of where to prioritize our repairs, where we want to advance the inline inspection interval, because inline inspection is a voluminous job. It requires heavy expenditure to do in the pipeline. We expend crores of crores in inline inspection, but sometimes we forgot. We defined by the law with the PNGRB and OSD, you have to do once in a 5 years or 10 years. But there are pipelines in which we have to do once in a 3 years also based on the risk. So here comes, this is very handy in picture. So basically it helps in optimizing the inventory spend. Then this is typically the results of the risk assessment which we did the pilot study in one of the oldest pipeline in BPCL. We have a Mumbai-Manmad pipeline on 256 kilometer that operates in the Mumbai city area and goes towards Nasik area. So we have a different kind of terrain there. So there we adopted this digital integrity management system, and slowly we are full scale implementation for the entire pipeline network. So here you can see this is the inline inspection corrosion distribution. Here you can see the red portion is concentrated at particular that location. So there are damage mechanism or there are chances of the coating damage. So we have integrated all the data in the single referencing system so that you can identify the root cause of that particular defect or that particular anomaly at that point of time. And here it gives you the risk assessment dashboard in which you can identify how many kilometers of pipeline is under risk, how many pipelines are safe, so that you will have a better picture as a management can see whether we are vulnerable at particular location or whether we are safe to operate in that defined pressure. Way towards sustainability. Basically, this system is developed based on the key assumption that we have a standardization in terms of the data set. Whatever data we are collecting from the field, it should be in the standardized format so that we have a better picture and there will be no uncertainty and in terms of the data compliance. The training and hands-on experience of the field staff is very crucial because the training part is taken, data collection is taken care by the technicians. So they become trained so that perfect data could be captured. GIS integration and the real-time data collection is in the development phase. We are integrating the mobile apps to collect the data. Then we have the advanced analytics system in which we are trying to use this data for the AI ML integration in the future. So this data becomes the backbone for the future scale or future rollout of the AI and ML predictive maintenance. So these are the key benefits that I have already spoken. We are shifting for the deterministic model to the probabilistic risk model, dynamic segmentation for the precise integrity planning. Then we have operational benefit. With this we could able to reduce our maintenance cost by at least 15% in one of the pipeline. And this is the sustainable and this is the future in terms of the digital and data-driven integrity management system. Thank you.
Thank you. Thank you, Mr. Keshav. After this transmission line, it's again a flow through the pipelines. So it is very important to have a sound integrated pipelines as it supplies major energy to our refineries, not only refineries but also to the common people. So integrity of this pipeline is very important, and adoption of the AIML tool is definitely changing the scenario right now. And from the maintenance to the predictive aspects, it is really making difference in overall asset integrity and making the system more reliable. Now I invite Mr. Vinay Gupta, Deputy Manager, Engineers India Ltd. He is going to present on the presentation on the small scale olefin complex, exploring how moleculars and optimal size petrochemical assets can strengthen India's petrochemical ecosystem while improving the capital and operating efficiencies. Mr. Vinay.
First, thank you for taking out time to be in this session. Just to start with, now from pipelines we move to petrochemicals, and bringing my experience in refinery, petrochemicals and feasibility studies, I'll be presenting a case study which will address a lot of a very critical issue in the area of niche petrochemicals. And the solution will be driven towards new investments of projects in the niche petrochemical segment. The insights are very different and can be debatable, but yes, this will definitely spark a lot of conversations in planning of new projects. Over the next 10 minutes, I think we'll be discussing on the visions and the plans and the targets which has been set for us for the petrochemicals. We'll be going through a case study which will support and also enable the strategy in this area, and also the key findings, what we find from this case study and whom it will benefit. Now, just going without further ado, I think let's dig in. In India, you'll find that at present in the global value chain in the petrochemicals, we are contributing around 3.5%, and which is expected to go to around 10% by 2040. thanks to the domestic demand in the petrochemical segment and the fast pace of urbanization which we are witnessing now. But yes, these are just projections. If you actually go and look into niche petrochemicals data and the data sources, you'll find that there are a lot of gaps. But I expect that there is going to be more demand because the way we are emerging as a country, the demand is going to be very fast paced in the future. So it's not just 10%, we can see higher growth. We are not only looking at sufficing our internal demands, we are also looking at meeting the international and competing with many other countries which are having a lot of advantage in niche petrochemicals. Just to take you through the petrochemical landscape in India, it's a very interesting thing which we witnessed. If you can understand that in product profiling in the country, you will find that polypropylene and polyethylene is very much concentrated based product in terms of petrochemicals. More than around 95% of propylene lands up in polypropylene and around 75% of ethylene lands into polyethylene, vis-a-vis the global average. What this shows exactly that the feedstock availability of the petrochemical intermediates are basically driven by the Indian players which are driving towards bulk petrochemicals. See, if you actually go and see many configurations, you'll find that there is very less ethylene and propylene or the intermediates which are left for merchant sale in complexes, which is actually not driving the niche petrochemicals. So we need to actually address this issue, look at the configurations a little differently and build a configuration so that we are in more competitive and we have a diverse product portfolio in niche petrochemicals. Now, just to take you around what we've been doing as a country right now, we have a lot of crackers upcoming in future and also operating ongoing. The general philosophy of a cracker is either from the associated sources, that is the LPG, ethane, or naphtha, or it is integrated with a refinery. The refinery integration is more prominent in India, and as you will understand, the refineries are going with higher capacities, which will always require a higher capacity of a cracker, and also in turn will land into bulk petrochemicals production. See, it's very important for a cracker of a 1500 to 1800 ethylene capacity size to evacuate its produce. So majorly you will find this is the product profile: LLDP, SDP, polyethylene. PVC is a product which has recently come into configurations, and PP definitely for major evacuations. Just for the case study, coming to the case study, we looked at various niche petrochemicals which are imported into India and have affinity towards ethylene and propylene feed as a feedstock. These chemicals have a robust growth rate of around 5 to 7%, and these niche specialty chemicals actually find a lot of way into our day-to-day lives in more of affinity towards the coatings, construction equipment as solvents. So this is a kind of a mix. This is not the only mix. You can always suit it as per your demand data. But yes, these are the chemicals we shortlisted for a case study. The capacities of these units which you see are based on the demands which we projected for the next 4 to 5 years. So just to bring it out, what we did, we took these chemicals and we conceptualized a complex with an cracker complex just feeding these niche petrochemicals. Now you'll find there's a small difference. The difference we find in what we found that when we are looking at a bulk petrochemical complex and a niche petrochemical complex is that the volumes in a bulk petrochemical complex is huge. You have a lot of storage volumes, you have capacities more than 500, but when you look at specialty chemicals, the unit sizes are small. And also it's not about the capacity of the produce, it's the capacity of the feedstock, because these are not 1:1 ratio of petrochemicals. The margins in specialty chemicals are quite fixed. They are not so volatile and they are very specific and customized to the product. to the downstream industry. You may appreciate that downstream industries do not change suppliers just because they want their product profile to be as constant and the grade should be as constant as possible. So you don't have so much of volatility as compared to a bulk petrochemical. Now, what we found after we did a configuration study, we found that yes, the returns from this kind of a configuration is quite robust. It is quite good. I would not say too good, but yes, good to consider. When you look at the capex loading of these, this kind of a project, you will find that almost like 25-26% of the capex goes into your naphtha cracker unit, and the cracker capacity, what we achieved is in ranging from around 375 to 550 kTPA. It's a very, very small size, mid-size cracker. But yes, we are operating one in India for one of the PSU clients in the range of 500 to 600 kTPA. You will always argue that the per ton capita of a cracker, capex and opex on a per ton of ethylene or propylene will be higher. But yes, it definitely is offset by the margins you get from the petrochemical. But why am I saying this? Who actually goes for it? What we concluded is that, see, it is not only the OMCs who are looking at niche petrochemicals. This is a market which is having a lot of distributors and a lot of medium level producers who have an opportunity to move towards up the value chain to produce specialty chemicals. In this kind of a project, you are assured of your feedstock. You have no dependence on the import. You have a lot of feedstocks available right from LPG to naphtha available in India. Go for assured captive feedstock generation for your complex. The capex investment is much lower than a bulk size unit. You have a very quick to fit investment project. You can always localize it to the demand center because you know where the main demand center for the specialty chemicals is. You can look for that area. And these projects actually go for a very low natural resources requirement like water, power. But yes, they are intensive, but they definitely require less. And with the lower capacities and more of the specialty chemical units actually go for modular construction. They favor modular construction, and in a cracker unit also, yes, people are working towards modular constructions. So with this kind of a project, as a country, we get a lot of opportunities so that foreign players actually try to do investments in India. You can also make a lot of joint ventures, look at various investment models to get these kind of projects online. Government already has a lot of policies about PCIR, PCPIR, PLI scheme. But one should understand that the same scheme may not be applicable for all the projects. We need to really work out, deep dive into such kind of projects and understand where the hand-holding from the government is required. So that actually makes this project more favorable, and definitely it adds to the vision of the country. Right. Thank you.
Thank you, Vinay. It's quite an interesting topic, especially after hearing from asset integration from transmission and pipeline. It's a different kind of topic where we are creating additional value added products from the refinery feeds, and it's really important that we should work on these aspects because it gives us import substitution and saves huge amount of our forex, and it's also aligned with the vision of our PM of Atmanirbhar Bharat. But definitely there are certain challenges, especially on aspect of technological availability of the technology, because many of the chemicals, the technologies are very guarded. So we have to work around those technologies, and definitely the margins for these niche products are huge. So thank you, Vinay, for the insightful presentation. Now I call upon Mr. Rahul Kumar Goel, Head Projects O&M from Adani Total Gas. He will discuss on the hybrid mathematical model for optimizing manpower planning in city gas distribution network an area critical to balancing safety, services, reliability and cost efficiency. Mr. Rahul.
Good afternoon, everyone. I am Rahul Kumar Goel, and I am with Adani Total Gas from last 20 years. We are into the business of city gas distribution. I guess many more relates to. We are into the business of laying gas pipelines and providing that gas as a fuel to CNG customers, industrial, commercial, and domestic segment. And I particularly operate in the northern part of this country, Delhi NCR, Faridabad, and also Gwalior, Jhansi, Lalitpur, Mauranipur area. So I thank Honorable Indian Government, the IEW platform to provide me this opportunity to present a framework, a simple yet powerful framework that will help the CGD companies to determine the manpower scientifically and not on the basis of intuition or the legacy-based system we currently have. So let me set the context and the problem statement directly. We understand geographical areas. If there is any CGD representative present here, they very well relate to. Geographical area is a combination of one or more district, and where a city gas company is licensed to provide natural gas, to lay the infrastructure to provide natural gas, right? So there is a very wide variety in these geographical areas. They vary from 1,000 square kilometer to 25,000 square kilometer. They vary from a sales potential of 10,000 standard cubic meter per day to up to 1 lakh, maybe more. But when it comes to the manpower planning, it is largely based on the intuition कि भाई उधर 4 बंदे भेज दो, उधर 6 बंदे भेज दो. So I tried to resolve that issue because I also face while I lay the project in various cities and various geographical areas, that we either tend to overstaff or we largely tend to understaff the situation. So for this, a mathematical model has been created with the help of the system. And yes, this is not an academic model, this is not a PhD model, this is not a consultancy model, it's a pure GA head model, geographical area head model. This will help CGD company to determine, to add to their decision. This is not going to replace the human judgment, this is not going to replace the leadership, but yes, it will help in deciding the decision. So just undivided attention of you people, 30 seconds. This is what the building, the fundamental building block, the hybrid equation. It has 4 constant and 3 variables. What are these 3 variables? A CD company can very well relate to. These are the 3 factors for which we tend to bid, we got the license and we operate and we earn some money. These are area, these are sales and the infra weight. Of course, area is what I just told you, 10,000 square kilometer, 15,000 square kilometer, 25,000 square kilometer. Sales is what in your own detailed feasibility report, your own analysis, you find out okay, that city, that GA might be having a potential of, let's say, 5 lakh of SCMD in 10 years, 15 years or 20 years. And of course the infra weight. Infra weight is a combination, is a unitless number, and it's a summation of your CNG station which you have given in your bid document, your domestic connection what we got the PNG in our home, your laying of steel pipeline. While these 3 make the part of license, there are other infra things which a CGD company do, which is providing connections to industrial, commercial like restaurant, hotels, industries like manufacturing industries. So this is what the equation tells us, that alpha, the first constant is you have to have at least a minimum number of person, even if you have 0 infra or this is your 0 dip. That alpha of course is customizable, but yes, for my sake of calculation, I took it as 4. And that 4 is a combination of a GA head and a project in charge and an admin staff and a business development staff. And less beta 1, beta 2, beta 3 are the other 3 constant, and these are again customizable. For my calculation, I have given 50% weightage to the area because that plays a very big role. Because manning a 1,000 square kilometer area is very, very different from manning a 25,000 square kilometer of area. And of course, sales weight, our bread and butter, and the infra weight, the number which you are going to do. Numbers are same, laying and operating a CNG station, providing domestic connections, providing connections to industrial, providing connections to commercial segments. And yes, that is where the heart of this calculation is, the ramp-up logic. Because what we do, we freeze the manpower in time. Manpower is a time function. The first year manpower will definitely is not equal to the manpower in the year 5 or the manpower year 10 or so. So what this ramp-up logic do, apart from deciding that project manpower, we simultaneously creating an asset which require constant operation and maintenance as well. So for this purpose, this is the next slide. What this slide is, we took the data, of course the data has been anonymized. We took the data of our peer CGD companies of last 5 years of all project segments. Project segment means CNG, industrial, commercial, domestic, laying of MDP, the plastic pipelines, and the steel pipeline. And we took the aggressive number. If any company has reported, let's say 10 CNG station can be done by one project engineer in an year, so we have taken into the model that 10 number. Okay, and similarly for industrial connection, it is approximately 75 numbers in a year. Similarly, 100 numbers of commercial connection in a year. And steel pipeline 11 kilometer. For the sake of calculation, I have taken it as 18 on higher side. So whatever this model is throwing us, we should be able to identify that that model is already tapered at multiple levels. We have already given the weightage in terms of area, sales, and the infra. And also at this, we have taken aggressive number. For example, domestic, you see the highest number is 2685. But in the calculation, I have taken as 5,000 domestic connection can be done by one engineer in a year. So by combining all these three, we can be able to do our manpower planning up to 15 years, 20 years, 25 years. And yes, very, very important, the terrain factor and urbanization factor, and of course the concurrency factor. Let me explain you what terrain factor is. As we all know, no two humans are same, no two projects are same. Similarly, no two GAs are same. A GA is blessed with a very normal good soil, very good urban infrastructure, where we get the permission very easily, very easy to lay the pipelines. And there is a GA which is blessed with hills, rocks, tough rocky strata. So the numbers which I have used in my ramp-up logic, if you remember the 5,000 domestic connection, so that 5,000 is on the higher side, but that would be for that city where the terrain factor is 1. That means where terrain is very good. Terrain is to the other side, to the CGD company. But if terrain is tough, there are hills, there are rocks, we face challenges, we face very, very escalation of cost on the laying of pipeline. So we use that number, let's say 1.3 for very hilly or rocky area. So we divide 5,000 by 1.3. So that means 5,000 of domestic connection in a normal GA would be equal to 3846 in a tough GA. So that is where the terrain factor plays a role. Similarly, urbanization factor, by the time we already have understood. If it is a good urban area, we would be getting nice roads, so very easy to lay the pipelines. And of course, rural area, we face many challenges, not many areas where roads are clear. And concurrency factor, because engineers are not supposed to be present at site all of the time. Not 24/7, 360. They are also supposed to do audits, the billings, they have to do the engineering, they have to do the planning as well. So whatever the number I am getting from that model, if I'm getting a 10 number of project and operation manpower from that model, so that concurrency factor will reduce it to 7. So if you are recording these stages, I have taken the aggressive number at the first stage, then the ramp up logic, then this concurrency factor. So even after that, I have myself find out that the numbers this model is showing is very nice, while the CGD company is having very, very less number. And yes, this is the coverage because this is basically a client-based model for CGD companies model. So we do have CNG project department, we have domestic, industrial, commercial project department, we have steel and industrial laying department as well. Similarly, we have operational and maintenance department of all these project departments. And of course, the logistics support department where we have light commercial vehicle SCV. If you have seen the cylinder cascades are moving on your roads, they are called LCVs or SCVs, which are providing you the CNG. And of course, the support staff of stores and inventory management, and also QA, QC engineer if you want to have, but GA head can do that part. And of course, the safety personnel is mandatory, and one admin staff and business development are already taken. So this is the output generated into the model, which is actually it's a very simple, but I have made that logic into an Excel sheet. I'm not sure if I'm able to show that Excel sheet here due to the limitation, but that is the output it is showing. Function-wise manpower, function means a project function. If project, what it is? It is CNG, it is project, it is industrial, it is commercial or what? And of course O&M, if you O&M what? CNG, PNG or what? GA-wise total, if various company have more than one GA, so that we call a portfolio. So portfolio summary we are getting GA-wise total. The entire manpower of a GA, and if more than 2 GAs, the portfolio summary as well. So this is what that model is throwing. So let me explain in detail. If you are saying this is the actual data, and I have just tweaked the numbers, but these actually represent the area which present in North India. One GA is having an area of 1,000 square kilometer, and one GA is having an area of 25,000 square kilometer, right? So what we easily assume that if we requiring 10% in an area which is 1,000 square kilometer, so that 25,000 square kilometer area must be throwing 250 numbers to us. No, because linearity assume that manpower increases with the increase in the area. So that's why if we remember the earliest formula, I have used under root of the area. That is not directly area divided by 1,000, because that in that case the manpower will grow linearly. So that will throw in unrealistic numbers. Similarly, the infra number is also tapered. So by using log 10, because infra numbers are very, very high, because people have quoted 2 lakh, 4 lakh or 6 lakh of domestic connection for a spread of 8 to 10 years. So that infra numbers are very, very high. If you starting using that number, so again we are getting very high number of manpower. So that is what it is. If you see that 1,000 square kilometer of area is actually a city, very well developed city in North India. And a city, this 25,000 kilometers is not a single city, this is a combination of 4 to 5 GAs. But yes, PNGRB, our own regulator, has given one license for these, okay? So you are saying that 1,000 square kilometer area is having larger manpower than 25,000 square kilometer area, because this model takes into the consideration the sales potential, the area, and the infra, because that 25,000 square kilometer of the GA is not very much developed as compared to GA5. That is, that demographic is of a little, there is a very less availability of four-wheelers, so there is very little less sales of CNG, and also very less concentration of industrial clusters, so very less industrial customers. So this considered everything into the picture, gave due weightage, and then we got the manpower into this form. So I also given this calculator to organizer of IEW. I'm not sure how they're going to share it with us. I have decided to share this with everybody, if every CGD company, free of cost, there is no money involved, but it's very easy to use. You have to just put your 3-4 numbers like your geographical area, your own infra number targets, which are MWP, minimum work program, which you have mentioned in your license. And of course, that minimum work program has to be divided up to 8 to 10 years. And then you put that number, you put your area, you put the weightage, and you'll get this number. So that is what it helps in the decision making. This is not going to replace any leader, because wisdom and psychology cannot be replaced. So this is not going to replace anything, but yet this will add into the decision making of an HR head or a GA head or a citizen company as a whole. Because sometimes GA head struggles with HR head कि भाई मेरे को 4 बंदे चाहिए, वो बोलता है यार 2 बंदे दिए तो हैं आपको, अब वो 2 बंदे उसको एक्स्ट्रा चाहिए, वो इस मॉडल के थ्रू अगर बताएगा तो डेफिनेटली ही विल गेट सम वेटेज, बिकॉज मैनेजमेंट इज नॉट इंटरेस्टेड इन इक्वेशंस. They just want the number you are putting up should be backed by a logic. So this is a presentation from my side. If you have any question to ask, thank you so much.
I thank all the speakers for their insightful contribution and audience for their attendance. With this, we conclude this session of asset integration and cost optimization. Wishing you all productive and engaging India Energy Week.